All right, welcome to today's webinar on modernizing mainframe DevOps with VirtualZ and GitHub. I am Dustin Froyum, one of the co-founders of VirtualZ, and today I have Vince Ray, our co-founder and chief technology officer. Hi, Vince. So,
Hey, good
Vince, I
morning,
think we'll
Dustin.
just talk a little
You're
bit
doing
about
well.
the Zaac architecture to start, and then we'll dive a little bit into DevOps and GitHub integration and what really makes Zaac different. And then we'll have a little bit of Q&A and conclusion. So Vince, you want to just kind of talk a little bit about the Zaac architecture and why it's so unique and now a patented architecture as well, an approach that Zaac uses.
Yeah, and I think, especially what we're going to talk about today in DevOps, the architecture of Zaac is what enables a lot of these features. Zaac is really just a way of having kind of plug-in virtual file systems on your mainframe on ZOS. And this should sound really familiar to anyone in IT because you've thought this way for generations on Windows and Linux and all sorts of other platforms. If you need to connect something to your Windows system or to a Linux system, there are plenty of ways of doing that. There's a device driver model there. There's all kinds of standards there, and there are many things have been written that support that model. We've just never seen that on ZOS for a lot of technical reasons that I won't spend a lot of time on. But mainframe IO has been kind of this closed box that you get what comes with ZOS, and that's really it. So Zaac is an attempt to kind of break that open and give you all the same things that you're used to on other platforms inside ZOS. So you want to use some cloud storage as mainframe disk? Sure, we can do that with Zaac. That's probably the primary use case. I can take an iSCSI server in your data center or something in the cloud or whatever it happens to be. I can provision a Zaac virtual disk or tape volume on it, and then my mainframe applications can access that virtually no change at all. They just do the normal IO they've always done, and that includes if they're doing low level things. If they're doing maybe it's a vendor product doing channel programming or some other low level thing, all that works fine with Zaac. Zaac captures that IO and transforms it into something that external file system can handle. So what's unique here is not just that overall architecture, um, but the fact that if you go a level deeper in that, what we've done is we've taken some industry standards and we've implemented them internally in Zaac. And very specifically, the standard I'm talking about is something that's really common on Linux called Fuse. And what that is a protocol for having file system drivers that just plug right into the system and can process IO requests using a very standardized protocol. And the reason that's important to the mainframe customer is that means that we kind of hit the ground with a lot of Fuse drivers that have been written for other platforms that can be ported to ZOS and work pretty much unchanged. I mean, certainly it's still porting that's required. There's still, details that need to be handled to make it run on ZOS. But by and large, we don't have to invent that. And it's not a closed and proprietary thing that we invented. It's something that's, pretty standard in the industry. So if we're looking to connect to Amazon S3 or iSCSI or any number of other things out there, generally the way we approach this is we go look at the open source community, we find that someone has developed that Fuse driver, port it, make it run on ZOS properly, and now we have that support too. So what that means is there's kind of an open-ended collection of things that we can connect to Zaac, and then every time we do this, your ZOS applications can interoperate with whatever's under the covers there, as though we're local disks. So yeah, I mean, Dusty, did you want to go into GitHub specifically here, or we're going to talk about that
Yeah, I think we'll
separately?
talk about that. We'll talk about that next. So, Vince, just a little bit more on the architecture. So, Zaac runs on the mainframe, essentially codeless on the target, whether that's in your data center or choose your cloud, right?
Yep, totally correct. Zaac is purely ZOS software. Nothing at all is required on the target side. It's not like you need an agent in Amazon or any of that. You just configure Zaac to talk to the storage that you want it to talk to, whether that's on-prem or in whatever cloud you want, or technically even another ZOS system. It doesn't
Mhm.
could be used that way as well. So yeah, very very simple, very easy to get going. All of the control is on the ZOS side, so uh, your security processing, all that stuff still happens under ZOS exactly as it would if there was a physical disk underneath. Except in this case, there isn't a physical disk. There's whatever you told Zaac to communicate with. And by the way, I should have stressed this before a little more. It's really that same paradigm for tape or disk. So if I want to create a virtual disk, sure, it works exactly as I'm describing, but I can also do the same thing for a virtual tape. I can have a virtual tape device on my mainframe, and then when I open and start doing I/O to that, what I think is a tape drive, it's going through that same exact process I described, it ending up wherever you've configured Zaac for that type of device. And by the way, and I'm sorry, slap me if I'm rambling too much, but um, one of the other cool things about the way we've structured Zaac is all of the things that I'm talking about can coexist uh, in parallel. So I could have one ZOS LPAR where I have one Zaac connection going to an on-prem iSCSI device, another Zaac virtual volume configured to talk, somewhere in the Amazon cloud. Excuse me, another one configured to talk to Azure. I mean, whatever combination makes sense to me is what I can do there. So mix and match as you see fit.
Well, that's perfect. I was just going to ask you about that. Kind of we have the duplexing architecture here, or it doesn't even have to be duplexing, right? It's really multiplexing. So Vince, you mentioned the Fuse driver, but and we're really kind of, as the primary are talking about just storage overall. Um, what other protocols are supported by Zaac if they want something something that's high performing, or they have something like SAN in their environment that they want to integrate with Zaac?
Yeah, well, certainly at least so far in our testing, the highest performance approach is all iSCSI based. Now that could be iSCSI to a SAN in your data center. That could be iSCSI to Amazon or Azure. That the idea is that iSCSI is a pretty thin protocol, and it's optimized for accessing storage devices over a network, and we get all the benefits of that. So if performance is your number one thing, and by the way, in a and I can't put numbers to this yet because we haven't had the chance to benchmark it in a real large client environment. But our feeling is that if I have a large mainframe environment and robust network, something like maybe 100 gig connections, I probably can communicate to that iSCSI device, especially if it's a SAN right in my own environment. There's probably not much difference in performance between that and local mainframe disk. The testing we've done so far kind of reveals that. So, we'll see if it scales up to big sites. But, if I'm trying to configure and I'm looking for, as close to mainframe performance as I can get, but, pennies on the dollar, a SAN with, an iSCSI layer is probably about the best you're going to do there. And just to put some context around that, I have a small device here in the lab, which I mean literally I can carry it. It's a little cube, just about a foot wide. The whole device costs just a few $1,000s, and it gives me up to 180 terabytes in this teeny little package that performs nearly as well as channel attached mainframe disk. So, I'm sure if we extend that to kind of higher end SAN devices and higher end mainframes that have, robust network in between them and their device, we think that'll perform really well. The other choice that's close to that is we also provide kind of out of the box NFS support. And NFS basically just means that we're accessing that remote system through what looks like a file. In other words, you could create, let's say you have an NFS server someplace, you provision a Zaac volume, you would see one file on that target that happens to be the virtual disk. So if your volume serial number is Zaac 001, you would see a file called Zaac 001, and we access that over NFS. And again, NFS is mature, standards based, and it's optimized for remote access to data over a network. So we get all of the benefits of the caching and the other advantages in that protocol. Beyond that, it really depends on the implementation. I mean, we certainly can support just about anything, Dropbox or S3 or Glacier or whatever you care to configure into it, as long as there's a Fuse driver that we can work with. So all of those are possible, but to an extent they're going to be all over the map in terms of performance. The trade-off, though, is that a lot of those will come with features that you might want to take advantage of. So like S3, for instance, comes with versioning. Every time I alter something on that virtual disk volume, I can configure S3 to kind of archive it so that I can do like point in time recovery. In other words, bring this back to the way it was last Tuesday at 4 o'clock in the afternoon. Those more advanced features that are built into some of these systems suddenly become available to you as well if you're using that. So it's like in all things, it's a trade-off between how much performance do you need, how much cost is involved, and how much feature and function do I get for that. My guess is that at least in the early days, many of the mainframe customers will probably cluster around that, all things related to the iSCSI protocol, just because it's really fast and relatively cheap for what you get there.
Yeah, and I'll just mention we have some other webinars. You can take a deeper dive into Zaac, particularly the journaling and the caching functionality, which are, again, really unique to Zaac in the marketplace. So, yeah, check those out or contact us, and we'll be glad to dive into that deeper with you. So, Vince, let's move on to kind of the DevOps and the GitHub story itself. So, um, maybe just talk about our integration with GitHub, and then what makes it a little bit different than other approaches to get to a unified code repository.
Yeah, and this was one that kind of jumped out at us really early in the development of Zaac. It turns out there is a GitHub Fuse driver that exists in the open source community. And basically in a Zaac context, what that does is it allows us to take a GitHub repository and think of it as a disk volume on your mainframe. So what you see, instead of kind of the normal Git, check in and check out and all of the processes that go around it, is you just see things like, here's a PDF that has my source code in it. The reason that's important is, certainly a lot of mainframe customers would love to standardize on things like GitHub for a lot of reasons. You might have, I don't know, legacy software, I'll call it, Panvalet and Librarian and STLM and Endeavor and all of those kinds of products. They tend to be expensive, and they tend, in a DevOps context, they tend to create integration challenges. If I check in some code, I might have builds to trigger in all of these different environments, and synchronizing all of that when you might desire to just have one copy of the code is a challenge. I mean, I've actually tried to do that with the way we build software internally at VirtualZ. We generally standardize on Azure DevOps, which is pretty close to GitHub, and we like the idea of using modern tools like Visual Studio and whatever to edit and kind of manage that environment. But at the end of the day, we have things like assembler language programs that need to get compiled on the mainframe. And unfortunately, it's not just check out the code and run the assembly. The assembler has relatively little support for things like macros in anything other than PDSs or PDSEs. So now I've got this ugly problem of, how do I get the source code to our macro libraries into a form that I can use as input to things like the IBM assembler. So there are solutions out there, but most of the solutions that we've come across are replication solutions. In other words, GitHub is my single source of truth. What I do is, as part of checking in a change, I make a copy of that and stage it in a PDF somewhere so I can run my assemblies against it. It's slow, it's cumbersome, error prone. All it takes is a network outage or something like that. Things can drift out of sync. And it often tends to be one way. So if I need to, I might have a mainframe developer who sees a problem, and really all he needs to do is edit some macro library someplace and make a really simple change. If he does that with, let's say, the ISPF editor, how does that change get back to GitHub? So, and again, there are solutions to this. It just it tends to be costly, complex, a lot of vendor products, a lot of moving parts that need to work properly. So we envision changing that. We envision I could just install the GitHub Fuse driver in Zaac. Now, if I do something like I just described, if I were to edit that macro library with the ISPF editor, What I'm actually editing isn't a PDS that's a copy of my macros. I'm actually editing the actual data in the source repository. So I don't have to worry about replication. I don't have to worry about synchronization. I don't have to worry about I got to use this tool for these functions and this tool for these functions. Everybody gets access to that repository the way they expect it. And that includes, even those legacy components. I can run the IBM assembler, specify, a data set that happens to be on a Zaac virtual disk volume. And really what I'm doing is I'm, reading and writing the GitHub repository. Behind the scenes, I get all of the GitHub functions. So if I needed to, let's say I need to revert that code to the way it existed, a month ago, I can absolutely do that. I get all the tracking, I get all the management, all the reasons people like to use GitHub get to be a whole lot easier. So, that's, it's kind of a different way of looking at the problem, but it makes a lot of these things that we kind of gloss over today just a lot more practical. I mean, this model, forget Zaac for a minute. This model works fine if you're, let's say, developing in Java, or maybe if you're developing in C and you're using Unix services and you're using, kind of that distributed mentality of how you build your application. It works fine in that case. Where you start to stumble is when you have things like, like the examples I used. I still want to use mainframe tools like the assemblers and that kind of stuff. I need to use maybe things like local editors on my mainframe. Maybe I have batch jobs that are doing, God knows what against the source code and some of the other files in there. That's where it kind of gets ugly to coordinate everything, and that's really a problem that Zaac can help us solve pretty easily. So again, it largely depends on what your goals are. If your goal is to share. And in other words, I might have some users. I mean, I'm myself like that. I'll plead guilty to this. I mean, I use modern tools quite a bit in the development process, but frankly, I've just been doing it for so many years. Sometimes I'm just personally more productive in things like the ISPF editor or one of the mainframe products like that. It's a personal preference. It's almost to the level of a religion with a lot of folks. So certainly you can say, what, we're not going to do that anymore. Everybody's going to use whatever it is, Eclipse or Visual Studio or whatever it happens to be, and you can kind of migrate. But there's a certain productivity hit that you take in doing that. Zaac kind of gives you the best of all worlds. Do whatever you want from wherever you want, and you're always working against one consolidated, centralized version of the source code, and the rest is really invisible to you. So again, I don't know that. Like I said, there are other solutions out here based on other vendor products that and open source technologies that many people use. Certainly Zaac is an alternative to many of those, but it definitely can make your life easier if you're trying to, especially if you're trying to exist in that hybrid model where you have different people doing different things from different places, depending on what their own preferences are.
So Vince, I just want to make sure, just being the development neophyte that I am, so in implementing Zaac, I can put my assembler code out in GitHub, and or let's just say it's Java code, right? That you're running on the mainframe. You put it out on GitHub. You have So a non-mainframe developer could have access to that Java code on GitHub, right? Edit, develop, and then goes back into GitHub and then is consumable by the mainframe again. Is that true?
Yep, exactly right. So, in your example, usually there's more than just the source code when we talk DevOps. There's usually automation and CI, continuous integration kind of processing. So, imagine the developer you just described. He's sitting on, let's say a Windows environment. He's using the Microsoft stack as the development tools. He goes to GitHub. He edits that Java program you're talking about, makes whatever change he makes, checks in, hey, I'm done with this, saves it. GitHub is going to trigger, potentially a whole pipeline of now what do I do now that I got the check-in? And part of that presumably is going to build the application somewhere. Now, in the case of Java, it's probably true that you could build nearly anywhere. But let's say a piece of that needed to be built specifically on the mainframe. So, GitHub could trigger that work for you as a result of the check-in. And when that tool, whether it's the Java compiler or whatever it is, when that gets executed on the mainframe, it doesn't necessarily have to do complicated, Git check out the code and do all this other stuff. It just references what it sees as a data set, and then a ZOS data set in a very conventional format, and it operates against that. It's operating against the code that developer checked in. It's the same, just one version of that code between what he did and what the mainframe is building from. And that's true. As I said, you could probably do most of that in Java and Unix services and all the things built into the mainframe today without too much trouble, because Java is pretty flexible in
Yeah.
how it sees its code. If that Java program happened to have a piece that was C or assembler or whatever it is, and I'll be the first to admit that's not really that common. If you're writing Java, you're probably not also writing assembler. But as an example, our Lozen product has that. We have to do certain security functions that are mainframe specific, and that's typically a job for assembler code. So we have a Java server application that needs to invoke an assembler module. So that kind of suggests that the build for at least part of that is going to happen on a mainframe someplace. So again, I can coordinate all of that in a lot of different ways, but with Zaac, that's pretty streamlined, pretty straightforward. I just reference what I need whenever I need it from wherever I need it, and I've got the data that I want there.
Yeah. So again, just simplified architecture uses it as the repository, integrates with your existing mainframe build and deploy environments and tools, but without any other really complicated intervening or just copying code back and forth, those types of scenarios. It's more of a native workflow from that standpoint, from the build and deploy process. Is that right?
Yep. And
Cool.
again, in a lot of cases, some of the repositories we're talking about get to be massively large. And and I'm not talking necessarily terabytes, but there could be thousands of files, there could be maybe tens of thousands of files. And so, when you go down that path of any of the replication solutions, that starts to get to be kind of an overhead kind of question. I mean, this was one of my issues. Like I said, I've tried to do this with without Zaac and with our products. And one of the things that I found is that a full build of one of our products was starting to take 30, 40, 60, 80 minutes, something in that range. So, I log in, I need to make a one-line code change. I click on the little save button, and an hour goes by before I can test it. That's not particularly good for developer productivity. I can't even begin to test that change for a while. With get all of that replication and everything else out of the middle of that, and that might go down to 3 to 5 minutes in our case. And again, our customers will typically run much bigger environments than we have. But the point is, even a couple of minutes is kind of annoying to a lot of developers. I know myself, I'm accustomed to kind of an interactive environment. When I write code on a PC or on on my Mac or something like that, I expect it to click the build, and in 10 seconds I have a version of the application that's ready to be tested. I'm certainly not going to tolerate an hour. And yet that's some of what's necessary if you hope to get to this. So there is an important productivity angle on this. There's an important just the brittleness of the environment that you can have that you're not going to want to live with if you're doing complicated things. So there's all kinds of scale issues, potentially security issues, all kinds of things there that just get a lot easier with Zaac in the picture.
All right. Anything else we should know about the Zaac integration, Vince?
Well, no, I mean, I hope that folks listening to this will kind of think of this as just, I think, we're talking specific to DevOps and GitHub, but it's really the overall approach that's important here.
Mm-hmm.
The fact that we can plug in a Fuse driver and suddenly take something that you'd never think of as kind of presenting this virtual disk interface to mainframe applications and leverage it. So, just as an example, I want to take some data from Salesforce.com. There's a Fuse driver out there for SFTC that gives us all of these same benefits. When it's a completely different use case, but it kind of follows that same pattern. And of course, if you're either you're a partner of ours, another vendor, maybe you're a sophisticated customer and you have some system that you want to integrate with the mainframe, you can work the same exact way I'm describing. That Fuse interface is public, it's not proprietary to us. So that means you have a let's say you had a reason to connect to Dropbox that way. You could write that. Dropbox could write that. We could write that. There are all sorts of possible approaches here that make this much more open than anything we've seen in the past.
Awesome. It's I think the simplification is really cool, and so we're excited to bring this to market. Overall, Zaac is just coming to market, as I think Vince mentioned. Particularly the iSCSI drivers that go along with it, and how that works. So, if you have some interest in testing that as well with us, please reach out. I'd invite you to join us. We've got we're kicking off our summer series of webinars here. So in June 3rd is our first one. We're going to talk about how to get IBM Z data into AI and make it usable within hours. And so that's a pretty unique capability that we have with our product set. And then on June 17th, that'll be the next one. We're going to talk about mainframe data, again, making it cloud ready, no code. All of our products are no code, particularly on the cloud side. There's zero code on the cloud side. So it makes it a pretty unique architecture in the market. We have a ton of other resources. We have a blog specifically on this topic. We have demos on demand of each of our products. We're going to be at a couple conferences if you'd like to meet with us in person there, or reach out, and we're glad to do a specific briefing into a particular use case. And then this will be available for playback on YouTube as well as our anywhere that you have podcasts. So our Skyward Data podcast we host. There's some great guests. All of our old webinars are on there in an audio version only too. So please check us out. All right. Thanks, Vince. Really appreciate you joining us as usual. And we'll catch you on the next one.